Hi and welcome back to Podcast School. This is an A2 Technology and Design video podcast. We're looking at the SEA syllabus, that's a Northern Irish syllabus, and we're continuing our look at electronics. In this particular podcast we're looking at logic simplification. Now, first of all, if you have not already watched the last two podcasts or the last three video podcasts, this stuff will make absolutely zero sense. So if you haven't, or if you've just stumbled upon this website, or you're watching for the first time, and you are interested in getting to know a bit more about logic and Boolean algebra, then definitely you need to watch the first two podcasts or the last two podcasts before you would watch this one, because right away I've said there, let's now put what we learned in the last two to good use. Alright, I've said there, look at this circuit below. Okay, we've got three inputs, A, B and C. We've got an AND gate here, an OR, an AND, and an OR. Okay, and well, it's not a complicated circuit, but my suggestion is that it's not actually minimal. And what I'd like you to do is to simplify this circuit, and the result should perform the same logic function but with less logic gates. So how would you do that? Well, let's have a look. So the first step is to write a Boolean expression for the output of the leftmost gates. So let's have this circuit again. So A and B is obviously inputs to that top AND gate. And remember, with ANDs we think of multiplication. So that's A and B. Here we have, yeah, you've got it, B or C. And with the lower AND gate, it's BC. Remember, ORs think of addition, and ANDs think of multiplication. So that's the first step. Step 2 then is to write a sub-expression at the output of the next set of gates. In this case we only have one, and that's that AND gate. So therefore it's BC times B or C, or BC and B or C. So that's just the combination of the step before, or the stage before. So that just leaves us with the output at where we had Q before. And yeah, Q equals A, B, that's up here, or, and then this lower term, BC, ANDed with B or C. And that's the expression for Q. So that's the full expression Q at the output in terms of A, B, and C. So what we must now do is use the identities that we've learned in order to reduce this Boolean expression. So first of all, we'll distribute terms. In other words, we'll multiply out the brackets. So we have AB, BBC, or BCC. Okay, so we've just multiplied out those brackets. Now, we're going to apply an identity here. We learned before that A and A equals A. By the same token, B and B equals B. So we can reduce the BBC term to just BC. So it becomes AB or BC or BC. Okay? And then we can apply the identity A or A equals A. So we've got BC or BC. So that must equal BC. So our next step in our simplification is this, AB or BC, because this term reduces down to just one. Now we can factor out B, take it out of the brackets in other words, and we get B and A or C. And in fact, if we write that as logic, we can see that this is our simplified set of logic gates. This thing should give us exactly the same function as the larger set of gates we had before. So what I now want to do is just check that. Just check to see if that is the case. If we were right, then these two logic functions should be the same. And the easiest way to do that is simply just with a truth table. Okay, so I've got ABC, And by now you should know that if you're writing A, B and C, or you've got 3 inputs, 3 variables, that will give you a total of 8 possible variations. Okay, because in fact you can work that out by 2 to the power of the number of inputs. So we've got 3 inputs, so 2 to the power of 3 is 8, and indeed we've got 1, 2, 3, 4, 5, 6, 7, 8 possible inputs. Okay, so let's go for D. I've labelled D up here. So that's just simply A and B. So we'll go down through D and we'll fill out that term. So 0 and 0 is a 0, 0 and 0 is a 0, 0 and 1 is a 0, 0 and 1 is a 0, 1 and 0, 0, 1 and 0, 0, 1 and a 1 though is a 1, and a 1 and a 1 is a 1. So that gives us D. Okay, let's move on to E. That's B or C. So we're looking at B or C here. So we're looking at these 2 columns to give us what E is. So 0 and 0, 0, 0 or 1 is a 1, 1 or 1 is a 1, 1 or 0, I feel like I'm doing bingo by the way, is a 1, 0 or 0 is a 0, 0 and 1, a 1, 1 and 1 is a 1, and 1 and 0, sorry, 1 or 0 is a 1. That's E. Okay, on to F. And F we know is given by C and B. So we're looking again at the same 2 columns, but this time we're performing an AND function on them. So B and C, let's go. So 0 and 0, 0, 0 and 1 is a 0, a 1 and a 1 is a 1, a 1 and a 0, 0, 0 and a 0, 0, 0 and a 1, 0. 1 and a 1 though is a 1, and a 1 and a 0 is a 0. Okay, now X is the AND of E and F. So simply just think of these 2 columns and as the output there, or sorry, X is the output. So 0 and 0 obviously is a 0, 1 and 0, 0, 1 and 1, it gives us a 1, 1 and 0, 0, 0 and 0, 0, 1 and 0, 0, 1 and 1 though is a 1 again, and a 1 and a 0 is a 0. Okay, and finally, for Q, it's D and X. So we're looking at this column here, and this column. So 0 or 0 is a 0, 0 or 0 is a 0, 0 and 1 is a 1, 0 and 0 is a 0, 0 and 0 again is a 0, 0 and 0 is a 0, and 1 or 1 is a 1, and 1 or 0 is a 1. So our final output Q is this 0, 0, 1, 0, 0, 0, 1, 1. Okay, that's the final column. Now, if we were correct in our simplification earlier, we should see the same thing here in the final output Q. Let's see. So it's much more simple this time. Again, we've got our 8 outputs. X is given by A or C. I'll not call these out this time. It's probably doing your head in as much as it's doing mine in. So I'll just click them through. You can check that you've got the same thing. Okay. Now this is the biggie. Q should equal the same as what it was before. Okay. So this is the function of B and X, by the way. And lo and behold, a few more clicks and I think you should see that they are the same. Brilliant. I'll just put them both up together now so you can see. There we are. There we have the 2 truth tables, and if I highlight both, look at that. They are both the same. So our algebraic identities gave us a very good solution. They give us the same outputs. Now we'll see that that's not always the case. Algebraic identities are good, but they're not the best way to actually simplify a circuit. Okay, and I'll show you an example of that a bit later on. But for now, you can see that these 2 things are the same. Okay then, until next time, bye bye.